Hey everyone, welcome to another video in this series about building a chat app in Flutter the right way. And in this video, we'll be looking at creating our local data source or data store, since the intent of our application here is to not save any messages on the server or in our databases, but that each message will be stored locally on each user's device. So with that said, let us get straight into this video. And the first thing I want to do is to go ahead inside of my pubspec YAML file. So now that I'm in my main Flutter area, not inside of the chat module, but inside the main Flutter area, I want to go ahead inside that pubspec YAML file, and for my dependency I want to add the chat module. So I'm just going to go ahead and say chat, and for this chat I'm going to set the path. The path will be my chat module. I also want to add the package sqlite. So I'm just going to go here, sqlite, since I'll be using this to store in the device's local database using SQL, or in this case sqlite and some of its helpful APIs. And as you can see, we have some error here, or it is still running the pubspec fetch. So now that we have our package installed, I want to go ahead now and inside of our lib folder, I am going to create another folder, and I'm going to call this folder models. And inside my model folder, I'm going to go ahead and create a local message. And this class will represent our message that is local to our client, in this case the Flutter client, separate from the chat module, because we do not want to directly couple the message that is in the chat module with the message representation inside of the client, which is really our Flutter application. So we're basically separating things so that when we create our local data source, it will not directly reference the message from the chat module, but reference the message from the chat module, but it will reference our local message or the client representation of that message. So I'm just going to create how I want the client representation to be. So the client will have a chat ID for each message, and it will have the message ID, and I'm going to make this private. And since it's private, I'm also going to give it a getter so we can get the private ID. I am going to give it also the message rather from the chat module. So this will hold a copy of that. We can import that directly from our chat module, and as you can see, we do not have access to it, and that's because inside of our chat module we have to go inside of lib source in here and export all those files that we want to use. So I'm just going to quickly go ahead and export those. So here, as you can see, I have gone ahead and exported all the files from the chat module so I can have access to them inside of the Flutter client. So now, if we should go back to our local message, we should be able to import that from the chat module, which is good. So now we have that. We'll go ahead and create also inside of our local message the receipt status of that message, and I'm just going to call it receipt. Then inside my constructor, I'm gonna say this message needs a chat ID. It needs a message from the chat module, and it needs also a receipt. And I'm gonna go ahead also and create those factory methods that I know I'll use inside of my data store or data source. So I'm just gonna say dynamic string for the map, and I'm gonna say to map, and this will return a map representation of this object. So I'll say chat ID, that will equals to the chat ID, the ID of the message itself will be equal to the ID from the chat module message, and I'm just gonna use the same fields from the complete message that we are receiving from the chat module, and I'm gonna use the spread operator here to say message to JSON, and this will basically explode all the fields of the message class inside of the chat module into its JSON object, and all those fields will become one with this map that we're creating here. And also I'll add our receipt, and I'll go ahead receipt, and I use the value. So this is our map representation, and then we want our another factory that will create our local message from map, or from the data that we receive from the local database. So I'll go ahead and I'll say final message. Here I'll create a message. This is the message from the chat module, and I'll say from will be equal to from the database, from the JSON that is received from the database, and all the other fields that are associated with the message, which I'll quickly type in here. So now that we have created our message from the fields in the database, I'll now create my local message, and for my local message I'll go ahead and say local message, and here I'll add the chat ID which is again coming from the JSON or from the database, chat ID, and I'll pass in the message here, and the receipt will be coming also from the JSON. So I'll go ahead and say JSON receipt, and that's it. And then because the ID is private, I'll have to set the ID here on the local message. So local message ID will be the ID from the database. And now I can go ahead and return my local message. So now we have our local message model set up, and I'm gonna go ahead and create another model, and this model will be the chat model. So let us create our chat here, and for our chat we'll have string. We have our chat ID. I want a integer which represents the number of unread messages in that chat. I also want the chat to have a list of local messages, and I'll call that messages. I'll initialize that to empty, and I also want the chat to have a local message which is the most recent message, and this will be for the displaying of the most recent messages for each chat on the front screen or the chat screen with the list of chats that we would normally see in WhatsApp or any other chat service. So I'll go ahead and initialize that. ID is a must, but I'm gonna make optional the list of message and also the most recent message. I'm gonna make those optional. Then I'll just create the same factory methods, the toMap, and for the chat, the only thing I'll be storing in the chat table is the ID for each chat. And you might be wondering, why store just the ID? So that I can fetch each chat and fetch the messages associated with that particular chat from the message table. So again, we have our from map, which accepts a map string dynamic just as before, and returns here a chat. And I'm just going to say map JSON ID. So I'm just going to create a new chat from the ID, no most recent message, and an empty list of messages. So that's it for my two models that is needed here. So now I am going to go ahead and create my data store, or data source rather. So again, inside of lib, just gonna create another folder, and I'm gonna call it data, and under that folder I am going to create another folder called data source, and under that I'm just gonna create the data source contract, and this represents all those methods that any implementation of the data source will have to use. So if you choose at some point to have your database stored remotely, then that's fine, but for now it's gonna store locally on the user's device. So for our data source, we want a abstract class I data source. And for the list of methods, I'm just gonna go ahead and add those. I want a method to add a chat to the database. So go ahead, import that from modules. I also want to add a message. This will add a local message to the database. And I'm just going to quickly create the rest of the methods and explain. So here we have all the methods that are necessary for our data store or data source, so that however we choose to implement our data source, whatever implementation we choose to have, whether it might be remote, whether it might be local, whether we might choose to store it in Firebase or some other place, wherever we choose to store these messages, the implementation will have to implement all these methods. So we have one to add a chat, to add the message, find a chat to find all chats, and update a particular message, find all the messages, and to delete a chat. So now that we have our contract set up, we can go ahead and create our sqlite implementation of this data source. So I'm going to say sqlite data source sqlite data source. This will implement our data source contract, bringing those methods. And since this is a sqlite data source, we will be using the database from the sqlite package. So we'll bring in the database API, and then inside of our constructor we will inject the database. So now we have access to the database, so we can now use the sqlite APIs to insert records to our table inside of our SQL database on the local device and manipulate those records. So the first thing is to add a chat. So what I am going to do is to say await. I'm going to access the DB handle, and there is a method called insert. So I'm going to say insert, and as you can see, it requires the table and the values that you want to insert. So I'm going to say insert into the chats table what values chat to map. So this represents those values. And optional, I want to add to this the conflict algorithm. So I'm gonna say if there's a conflict, go ahead and replace that record. So that is our add chat method. And similarly for our messages, I'm just gonna go ahead and copy this and say instead of chat, I'm just gonna insert into the messages table. So messages, and I'm gonna insert message to map, and the same thing with the conflict algorithm. where there's a conflict, go ahead and replace. And for the delete chat, it's pretty similar, but I want to delete, when I delete the chat, I want to delete it from the chat table, but I also want to delete those messages associated with that chat from the messages table. And I want to do all of this in one transaction. I do not want it to be a bunch of isolated calls to the database, but one transaction. So to do this with sqlite, there is something called a batch. So what you do, you go ahead and you say db and you say give me the batch, and then you perform the delete operation on the batch. So you'll say batch delete, and you will delete table. You're going to say delete from the messages table. I'm going to delete the messages first, and I want some conditionals here. So I'm going to say where the chat ID equals question mark, and this question mark will be replaced with our where arguments. So now I'm gonna add our where arguments, so where args, and for our where arguments I need only the chat ID. So that basically runs a query that deletes from the chat from the messages table, where the chat ID is what we pass into the function here. And the same thing is for the chat. So I'm just gonna go ahead and copy this, and change this to chats, and instead of where chat ID, it's now where ID. And then we can say await, and we commit the batch. So batch commit, and we want no result. We do not want it to return any data from this delete operation, which will result in more resource usage to return this information, since we are not using it. So now for our list of chats implementation, this one is slightly more involved. So for our list of chats, how we're going to do this is that we are going to create our chat. We're going to fetch our chat from the database, but with those chats we want to fetch all the messages associated with each chat, and also all the unread messages, the count of the unread messages, and the most recent message with that chat. So we have, it's quite involved, and a couple queries to write. So here again, we want to do all of this in one transaction. We do not want to do it in, how I would term it, line by line, or we do not want to do it synchronously, waiting for one thing to finish then the other thing, but we want to put it in a transaction that it runs together as a group and return the final result. So for that, we have what is called db transaction, and this accepts a method, and then we'll run each query on this transaction object. And We do not want to use the DB object to run each query because then we'll cause a deadlock inside of the database, and we want to avoid deadlocks because we know that deadlocks are bad. So I am going to say find first of all the chats with the latest messages. So first I'm going to create a variable known as chats with latest message, and this is going to be a raw SQL query. So I'm going to say await on the transaction object. I am going to run a raw query, and inside this query I'm going to use a multi-line string, and I'm going to say here select messages, which means select all the fields from the messages table from, and this from will come from a subselect. And if you are not familiar with SQL language, this might seem strange to you, but I am going to select all messages from a inner query that is joined to the messages table. So now I'm going to create this inner query, and this inner query will return the latest message or the most recent message for each chat. So for this query, I'm going to say select, and what I'm going to select is I'm going to select the chat ID. I'm going to select the maximum and a field called created at. So max mean the latest message based on date time when it was created. I'm going to name that column as created at, and this I'm going to select from the messages table. So I select that from the messages table, and I'm going to group it by the chat ID. So this inner query is basically returning the latest message and the chat ID that that message is associated with. So when I receive those latest message, what I'm going to do now is to name this return table as latest messages. So I'm getting all the latest messages, and now I'm gonna join using an inner join the latest messages on the message table or messages table, and I'm gonna join on two fields, right? I'm gonna join on messages, so join on the fields messages chat ID is equal to latest messages chat ID and messages created at is equal to the latest messages created at. Again, if you're not familiar with SQL, this might seem a bit involved, but it's selecting all the chats with their latest message in one query so that we do not have to be running multiple queries to get the desired result. So now that we have those chats with the latest message, I'm gonna go ahead and run another query in the transaction that will find the chats with unread messages. So the first query find all the chats and all the latest messages on those chats. Now I want to find all the chats with unread messages, and this one is pretty simple. So we'll take our transaction object again and we'll run a raw query, and this time for our raw query we'll simply say go ahead and select chat ID count all and name it unread. I'm gonna say this from messages where the receipt is equal to the value that we'll pass in, and I'm gonna group by the chat ID. So now I want the value I'm passing into the where clause is where the receipt is equal to the delivered. So if the receipt says the message is delivered but it wasn't read by the user, then I flag those messages as unread, so we can know the number of unread messages for each chat. So now that I have that, what I'll do is to say return chats with latest message, and I'm going to map that, and I'm going to create a list, create a chat. I'm going to map it to a chat object, and I'm going to say row as the element. Then for each row, I'm going to say final int unread. Now I'm reading each chat. I'm going to say int try and parse chats with unread messages, and I'm going to say first where, and the where clause here is first where the element so the row that we're working with, where the chat ID in that row is equal to the chat ID from the chats with unread messages. And also here I want a or else, so that if the chat is not found, I'm just gonna return this map unread equals to 0. And then now for my count, I'm just gonna capture that unread map ID. So this or else should be a method. And now we have our unread messages for this particular chat that we're now processing. So now that we have that, we can say create a chat, find all chat, be chat from map, and we just pass in our row, and then we can say chat unread equals to unread, and then we can say chat most recent will also equal to local message from the row. Then we return this chat, and we here cast it to a list since we want a list of chats, and we return this directly so that we're returning a list of chats. And this might seem a bit complicated for some of you guys, but if you really go through it line by line, then you will see clearly what is happening here. So that is for our find all chats, and next we'll move to find a single chat. And I'm just gonna go ahead and implement this and explain it, since it's somewhat similar to what we have just done with the find all chats. So here we have our implementation for finding a single chat, and it's pretty similar. We run this inside of our transaction object, and the first thing we do is to find the list of chats by using transaction object to query the chats table where the ID is equal to the chat ID. So that's our list of chat records that are stored in the database. And then we find the unread messages for those chats. So again, we'll say we'll use this sqlite helper method first int value, and we'll pass in a raw query that says select count from messages where the chat ID is equal to the chat ID that we passed in, and the receipt is equal to delivered. So basically what's happening is we are counting on the database the number of messages that are unread for this particular chat. And the same thing with the most recent message is that we are querying the database, querying the messages table where the chat ID is equal to the chat ID that we pass in. We are ordering by the created at field in descending order, and we're using the limit of 1. So basically what this is saying that we order each message associated with this chat, but we order it in descending ID, we order the table in descending fashion so that the latest message will always be at the top. And then we say limit 1, which means get the latest message, get the first message, which is the latest message, at the top. And then we say chat, and we pass in the list of chats, and this is an array, so we have to pass in the first one, which will be a single element, since it's only one chat associated with that ID. And we set the unread message, we set the most recent from our local message, and we return the chat. And that's it, pretty similar to what we have done before. And for our other two methods, find message and update message, we'll simply say list of maps will be, I'm just going to use the database object here to query, and I'm just going to use the query API instead of raw SQL here, because simple cases like this we do not need to use raw SQL. But for the complicated ones, like the finding all chats and getting all the different parts, it's best to use raw SQL if you understand SQL to that level. So I'm going to say get it from the messages table here, where find messages, where chat ID equals to my where args, and I'll pass in my where args here, which is the chat ID. Then I'll simply say return list of maps, and I'm going to say map that to a local message, and here I'll pass in the map and I'll just return local message from map and say convert it to a list, and that's our list of messages for that particular chat ID. And for our update message, it's pretty similar. We'll simply run a update query where the message ID is the ID of the message passed in. So what we're doing here is to call the update method on the database object. We pass in our messages table, since we want to update our messages table, and we use our message map where the ID is equal to the message ID here, and it should be message ID, that is the local message ID. And just to be clear, let me see local message from map, and we have the ID here when we say to map. So it's best to get the message ID from the message from the chat module instead of the local message in this instance. So now we have all our methods implemented and ready to go. So to test these methods, we are going to go inside of our test folder here, and inside of our test folder I am going to create a data folder, and inside there I'll create my sqlite test. And to really do this test, I am going to need the Mockito library, since I'll have to mock the sqlite database object in order to test that my method, and this test will is basically behavioral test verification that the appropriate methods are called. Since we cannot run integration tests directly on the SQLite database, since it requires a live and active device to run that kind of test. But we can use Mockito just to verify that everything is working as it should. So I'm just gonna go here and I'm gonna say go to PubSpec and add the Mockito library. Let's move that down to our dev dependencies. And I'm going to use Mockito 4.1.4 to avoid a dependencies issues. So now that we have that set up, here we can go ahead and mock the database class. So I'm just gonna say class sqlite mock sqlite database extends mock and implements the database from sqlite, bringing that from Mockito. And I also want to mock the batch object. Extends mock, implements batch, again from the sqlite library. So now my system under test is my sqlite data source, and for my database I'm going to use my mock database. And my mock batch. So now inside of my setup, I will go ahead and say database is equal to mock sqlite database, and I'll have my batch and also now I initialize my system under test, my sqlite data source, and pass in my database, which is great. I'm just gonna create a message here that we will use. So we have message, we create a message from a JSON object that we will use. And there is an issue with testing timestamps inside of our message in the chat library. So if we go inside the chat library, go inside of models and open the message file, then where we have timestamp, okay, I think we have the correct timestamp here. So this should be okay. So now we have our message set up here. And for our tests, I am just going to write each test and then explain what is happening. So for our first test, I am testing that the chat record is inserted into the database. And so what we're doing is to use Mockito to say whenever insert is called on the database object with these particular parameters, chats, insert is called on the chat table with the chat map and the conflict algorithm being this, then I'm going to say return 1. So what this is doing is calling the method from the mock object instead of the real database object. And as I said before, we cannot use the real database object because we need the application to be running on an actual device to access the database layer of that device. So we have to use a mock object here to basically simulate what will happen on the database and to verify that the correct methods are being called with the correct parameters and values. So we go ahead and say SUT, we add the chat, and then here is the verification. We verify that the insert method was called on the database object with the chat table, with the values from the chat map, and with the conflict algorithm being replaced. And this should be called only once. So this is basically verifying the behavior of our system. It is not validating the output. It is not determining whether or not the output is correct, but it is verifying the behavior. So if we run this test now, we should see whether it passes or not. And there we have a passing test verifying that the behavior of inserting a record, a chat record inside the database is actually correct. So I'm just gonna go ahead, write the other tests and explain similarly. So for this test, we are checking if the insert is performed on the message table to insert a new message into our database. So again, for our arrange, we set up our local message. Then we configure our mock object to basically return 1 whenever the database insert is called on the messages table with the values from our local message. And then we call that method on the system on the test, pass in the local message, and verify again the behavior that the appropriate method was called with the appropriate set of values. And if I run this test again, let us see what will happen. We also have this test passing, as you can see, our green light here, and that is wonderful. So we are verifying the behavior of our data source. So for our next test, I'm just going to go ahead and write that. So for this test, I'm verifying that we are performing a database query and return a message. So I have here a messages map as a message would be represented in our database. These are the fields that will be stored, how the message will be stored. Then again, I'm saying when we call a query method on the messages table and we have a where condition, any named where argument, and again our args or where arguments can be any name, then return this message map. So whenever we query the database, return this object as a record that is found in the database. So we call or find message, we pass in the ID. This will return this message map that we set here. And so we are expecting that the SUT will return a message. The message length should be 1 since we have only one item in the array here. And we expect that the chat ID for that message should be 111. and we are verifying that the call to this query method was called only once. So if we run that test, we have a failing test which says string is not a subtype of receipt status inside of our local message. So inside of our local message here, we are saying this string here, this should be a receipt status and not a string. So to fix that, we need to use our enum parsing extension method. So enum parsing dot from string, and then we'll pass in the receipt string. This will then give us the appropriate receipt status based on this string. So if I save that and go back to my test and run my test again, now I have my test passing. And I'm just going to go ahead and create the remaining 2 tests and explain that to you guys. So for this test, I am verifying that an update is performed, and it's pretty similar to what we have been doing so far. So we have a local message here. We have our Mockito setup that says whenever this database object, the update method is called to this table with these values, then return 1. And I go ahead and call update message, pass in the local message, then verify that the method was called with the appropriate values, and it must be called once. So if I run that, there I have my test passing. And the final test is the one to delete the chat using the batch. So here I say that when the database batch method is called, and when this method is called, it returns a batch object. So what I'm saying here, when this method is called, return my mock batch object, because I want the operations to be performed on my mock batch object. So now when I say sqt delete and pass in the chat ID, here I am verifying that the methods are called in the appropriate order. So now I'm verifying that the database batch method is called, which will generate the batch object, and then from that batch object I am verifying that the delete method is called to the messages table with the appropriate arguments. Then after, I'm verifying that the delete method is called to the chats with the appropriate arguments, and then the last method to be called on the batch object is the commit method with the no result true flag. So this is the order that I'm verifying that each method should be processed in. Again, these tests are verifying behavior rather than outputs, because we cannot verify the output since we cannot access the database directly without an actual device. So if I go ahead and run this test, then I have my test passing and verifying that everything is working as it should. So we have completed all our tests here. Everything is behaving as we expect them to behave, and that's good. So we have completed our chat, our local message, and our local data source in this video. And in the next video, we'll be looking at creating our view model and how it will represent interfacing with these chats when each message is received from the real-time stream. So again, thank you guys for tuning in, and for being patient with these videos. It can take some time to really sit down and to come so that the software can be designed well, and not just to give you guys the same old set of information, but to actually try and give you a development perspective from how things work in a production setting so that you guys might grow as Flutter developers. So thank you for watching, thank you for tuning in, and see you in the next video.